Hello, my name is Nigel Griffiths. I work in the Advanced Technology Centre in the UK, part of IBM Europe. This Back to PowerBasics movies is about logical partition and the disk options that we have. We can directly connect internal or external SCSI or SATA disks. We can directly connect fiber channel or SAN disks. But we can also have virtual SCSI disks that are any of the types above, and they'll be connected via the VIO server, and we'll concentrate on this area. Let's look at three different logical partitions here inside one machine and how we can directly connect storage to it. Typically we've had SCSI disks for many years, and we can connect those to our machine and connect them to a particular logical partition by making the adapter that they're using in the logical partition. If the disks are internal, we typically have a SCSI controller on the back plane, or the motherboard as you'd say for a PC. This looks like an adapter slot, even though it really isn't. Or it could be a PCI adapter in an adapter slot with a cable out to our disk subsystems. Sometimes these adapters can be clever in the sense that they can run RAID 5 themselves on a group of disks that are connected to them. Well, we all understand SCSI disks, they've been around for years. In more recent years though, we've had fiber channel. These are fiber channel adapters inside the machine. We can allocate those to a particular logical partition. Then we can cable those up to a SAN storage area network, and then eventually we'll connect them to a storage area network disk subsystem, in which there's a whole group of disks and we manage them as a set of disks. That management software allows us to make a LUN of some sort out of those disks, and that LUN, a slice or a section of disks, is presented as a disk to the logical partition, and then it just accesses the disk. Even though it isn't really a disk, it's an abstraction of the disk. It's a sort of virtual disk in its own right there, but we won't be using the virtual in that sense of the word. Of course, we are worried about the reliability of our access to those disks, so typically we put in two fiber channel adapters into our logical partitions inside the machine. Then we have two sets of cables, two switches, and then we make disk protection on the disk subsystem itself, so that we're fully safe and redundantly reliable access to our disks. Of course, that comes at a price. Each logical partition here would need one or two of these fiber channel adapters, and fiber channel adapters are quite expensive. Now imagine, if you will, we're not going to have just a handful of logical partitions on the machines, but we're going to have tens or perhaps hundreds of small logical partitions on our larger machines. Perhaps we're doing server consolidation, and we're bringing on a workload that took an entire machine 5 years ago. When it's on a machine these days, it's actually fairly small and only requires a fraction of a CPU, a few gigabytes of memory, but we still need access to our disks. If we have 100 logical partitions, it's impractical to have 200 fiber channel adapters connected to them, so we're going to have to use virtualization to get around this. Inside the machine, we're going to have our clever firmware. We call it a hypervisor, and the hypervisor can be used to create virtual SCSI adapters inside the machine. These will appear like a real adapter, but there's no actual physical hardware inside the machine behind them. Then we're going to introduce something called the VIO server, and it too will have these virtual SCSI adapters, and we can connect these adapters together, so we have pathways over the hypervisor between the virtual I/O server and the client logical partitions. Now there are various things we can do inside the virtual I/O server. First of all, whatever the disk is we're connected to, whether it's a internal or external SCSI drive, or the new SATA drives we get in the PowerBasics machines, or it's a LUN out on a SAN disk subsystem. However it's presented to the VIO server, it has that disk online, and out of that disk or a set of disks we can create a logical partition. That logical partition then can be connected to the virtual Ethernet adapter, and so the client thinks it has a disk attached, but it's actually a logical volume on the VIO server. Another way of connecting the remote disks via the VIO server is that the VIO server can have that disk online. It creates a file system on that disk or set of disks, and then we create a large file, maybe an 8 or 16 gigabyte file in the file system, and we use that to back up the disk that the client sees. Again, the client is unaware of how the virtual I/O server is actually accessing the disk. It sees a whole disk, and it's unaware of the fact that it is actually a file in a file system on the virtual I/O server. So that we have logical volume and we have file-based virtual disks. Now, of course, we may want to make sure that we have disk protection in here. If these are simple SCSI disks, then one way of doing that is that we could have two VIO servers and have matching pairs of either logical volumes or file-based virtual disks. And then the client logical partition can mirror between the two VIO servers, the two logical volumes or files, out onto two separate different disks. Now let's ignore that second VIO server for a while, because there's another way we can connect this up. In this case, the virtual I/O server is aware of the external disk. Again, it doesn't matter what sort of disk it is, but it passes the entire disk, not a part of it, a logical volume or a file in the file system, but the whole disk to the client logical partition. This means that there's no sort of mapping inside that the virtual I/O server has to do. It effectively passes the read and write instructions to and from the disk, and the whole disk is presented to the client logical partition to do its I/O. Of course, again, you might want to have a second disk on a second virtual I/O server. Then the client logical partition sees two disks and it can mirror between those disks. Alternatively, if that whole disk is actually a LUN in a fiber channel disk subsystem, then we could allow the two paths to run, one through each VIO server, and use multipath I/O in the client. We actually have one disk here rather than two, and it's the responsibility of the disk subsystem to provide protection, either mirroring or RAID internally. We're unaware of how it's actually doing it. It looks like a single LUN or a single disk as far as the logical partition is concerned. Now, in the next movie about virtual disks, we're going to demonstrate the following about how we actually set up our virtual disks using our virtual I/O server. On the HMC, the Hardware Management Console, we create these virtual SCSI adapters, both in the client and in the virtual I/O server, and we connect up those virtual adapters so that the I/O will actually transfer between the logical partitions, the server and client logical partitions. And these connections are all exactly the same regardless of what underlying disks are involved. In the second part, we're going to look at how we do this, creating the disks and the mapping of those disks to the virtual SCSI disks for the logical volume based, the file system based, and the whole disk or LUN based virtual disks. In a further movie, we'll demonstrate dual virtual I/O server working, where the clients will either mirror between disks or use multipath I/O when they're referring to a LUN. Now, before we finish this movie, a quick word on the virtual disk performance. Disk I/O comes in two parts. There's the control information, which are tiny I/O requests, literally a few integers in size, and then we have the data movement, where the large data blocks come to and from the disk into memory. The control information is what flows across the hypervisor between the virtual I/O adapters, between the logical partitions requesting the data and the virtual I/O servers supplying it. The data movement is actually done directly using a technique called remote DMA. So the device drivers running in the virtual I/O server communicate directly from the disks into the memory space of the logical partitions that requested the data. This means it's very efficient. The data isn't copied first into the virtual I/O server and then moved into the client logical partitions, because this would take quite a lot of CPU time. This means that the performance of our virtual disks is actually very good indeed. I'll leave you then with this summary of how virtual SCSI disks are connected.